In the development of the 1D steady formulation, we defined T hat equal to the sum j equals 1 to the number of nodes, Tj times Nj, where Tj is the coefficient of the jth node, and Nj is the basis function associated with the jth node. What is implied here, but never actually said explicitly, we know that T hat, which is temperature, is going to be a function of time, and it's going to be a function of space. And in our case, it's 1D, so it's just x. And what this means is that our definition, Tj, is a function of time, and Nj is a function of space. And in higher dimensions, Nj would be a function of more dimensions. So this makes sense to us because we've basically said, the Tj's, they're the values at the nodes. And we know that because they're the values at the nodes, they are not functions of x. We haven't considered time at all until now, but it's clear that for an unsteady problem, these Tj's, so if we say that n plus 1 is our next time step, it's not necessarily going to be equal to the time step that we have now, nor is it going to be equal to the previous time step unless we're at steady state. Likewise, consider Nj. Nj is equal to a function of x, and we saw this explicitly in the definition of the Lagrange polynomials. Furthermore, based on this, we were able to expand the spatial term, so we were able to expand dt dx, dt hat dx, this spatial term, to say that dt hat dx was equal to d dx sum of j equals 1 to n nodes, tj nj was equal to sum j was 1 to the n nodes of tj dnj dx. In the unsteady case, we need to consider the temporal term. So we have 0 to L w sub I dt hat d time dx. And if we use our definition, then we can say 0 to L w sub I d by dt sum over j, where we'll know that it goes through all of the nodes, tj nj dx can be simplified to 0 to L w sub I sum over j nj dtj dt dx. And now in this short video, we have considered T hat as both a function of time and space, and we've shown how we incorporate both the spatial term, that in particular expanding the d by dx of our sum over j, t sub j, n sub j, and now we've expanded our d by dt of the same term. We're now ready to go to the next video where we expand and we develop how we approach solving and implementing the formulation for that temporal term dtj dt.